Hello friends, welcome to VANI Institute. In this video, we are going to discuss KPSC Assistant Engineer Civil Question Paper for the year 2017. Before starting the video, a small announcement. Right now, admission are open at our institution for GATE, ESC, KPSC and KPTCL. Okay, now let us start our discussion. So this is a question paper. This is set A. And if you see this question paper is given in two languages. One is Kannada and another one is English. Here in this video, we will be discussing the question in English only. Okay. So let us start our discussion. So let us first solve question number 30. So this is question number 39. This question is from strength of material subject from shear stress topic. Here in this question, it is saying that there is a right angle triangle having a base of 50 mm and height of 75 mm and its base is horizontal. So base of the triangle is horizontal. That means our triangle is like this. Okay. So here base is horizontal. Okay. Now this triangle is subjected to a shear force of F. So here shear force is equal to F and moment of inertia is I. Now in the question it is asking us to find out shear stress at the axis passing through the centroid. So he is asking us to find out the shear stress at this axis, and this axis is passing through the centroid. We all know that the axis which passes through the centroid is a neutral axis. So in the question it is asking us to find out shear stress at a neutral axis. Okay. Now to find out this one, let us consider this triangle, and this triangle is having base equal to 50 mm and its height, this height h is equal to 75 mm. Okay. Now to find out this value, first I have to find out tau max. Okay, so I can say that tau max is equal to fh square by 12I. You might be wondering how I got this relationship. Okay, actually this relationship we will be getting while solving tau max equal to 3 by 2 times of tau average. Okay, to achieve this relationship in between we will be getting this value. Okay, so I will tell you how we are getting this value. Okay, so we all know that tau average is equal to, okay, so tau average is equal to shear force by area. Okay, so that only I will substitute here. So tau max is equal to 3 by 2 times tau average is shear force is F here. So area of the triangle is half into B into H. Okay, so here 2 will get cancelled. So I will get tau max equal to 3F by BH. Okay, so from this equation I am right. What I will do is here I will multiply h square and divide h square here. So I will be getting 3f h square by bh cube. Okay, now after this what I will do is in the denominator I will multiply 36 and divide 36 here. Okay, so I will be getting here 3 ones are, this is 3 12s are. So I will be getting here fh square by 12 into bh cube by 36. We all know that the moment of inertia of a triangle is equal to bh cube by 36. So this whole term I can write it as I here. So I will be getting tau max value equal to fh square by 12I. So this is how I am getting this relationship. Okay, so let us continue our problem. Okay, this was small explanation for this relationship. So now I got tau max value equal to fh square by 12i. Okay, now I know what is h here. Okay, now if I substitute here, I will be getting tau max value equal to 468.75 f by I. Okay, this is tau max value. So we all know that I will use this relationship. Okay, tau max is equal to 3 by 2 times of tau average. Okay, so if I use this equation, that is tau max is equal to 3 by 2 times of tau average. So here in this place I will write down this thing. So 468.75 f by I is equal to 3 by 2 into tau average. Okay, so after simplifying this equation, I will get tau average value equal to 312.5 f by I. Okay, so I got tau average value. So this is tau average value. Okay, for triangle, we all know that for triangular shape, tau neutral axis is equal to 4 by 3 times tau average. Okay, now if I substitute tau average value here, so 4 by 3 times of tau average is this value. So 312.5 f by I. Okay, so if I simplify this equation, I will get tau neutral axis equal to 416.66 f by I. Okay, so this is my required answer. If you see the options, if you see the 4 option, option A is correct answer. Okay, so this is our required answer. Now let us discuss problem number 62 from set A. This question is from, you can say, from geotechnical engineering. Okay, or you can also say it is from environmental engineering, from sedimentation chapter. Okay, so if you see here, there is a 50 gram of oven dry soil, okay, having 5 different sizes. Okay, so the largest size here is 0.06 and the smaller size here is this, sorry, this is 0.004. okay, so here the smallest size is this. Okay, so now he in this question it is saying that they have conducted a hydrometer analysis and 100 cubic centimeter of suspension is prepared and filled in a jar up to 30 centimeter height. Okay, and if the specific gravity of soil is 2.7 and dynamic viscosity, here in the question it is saying only viscosity, that means it is dynamic viscosity. Dynamic viscosity mu is equal to 1 into 10 to the power of minus 6 kilonewton second per meter square. Okay, so time required in the question, he is asking this, time required for all the particle to settle down at the bottom of the jar. Okay, so he is asking what will be the time required for this 5 particle to completely settle down in the jar. Okay, now to find out this time requirement, we have to use the Stokes law. Okay, so in the Stokes law, settling velocity is equal to g into density of particle minus density of water into d square by 18 mu. From this relationship, I can say that settling velocity is proportional to d square. That means greater the diameter of the particle, greater will be settling velocity. Greater the settling velocity, less will be the time required to settle. Okay, the faster is the settling velocity. Okay, so less time will be required to settle the particle. That means I can say that greater the diameter, lesser is the time required to settle down. So maximum time will be taken by the smaller particle to settle down. So we have to target this particle. Okay, we have to see that how much amount of time is required for this particle, this smallest particle, to settle down. So here let us first find out the settling velocity of this smaller particle, particle number 5. Okay, so in the question they have given settling velocity, specific gravity is 2.7. So density of the particle will be equal to 2.7 into 1000. So density will be equal to 2700 kg per meter cube. Okay, now density of the water is 1000 kg per meter cube. So, and viscosity is given as this much, but it is in kilonewton. To convert it in Newton, it will be mu equal to 1 into 10 to the power of minus 3 Newton second per meter square. Okay, so now let us find out the settling velocity. Okay, so Vs will be equal to G is 9.81. Density of the particle, this is 2700, minus density of water is 1000. Okay, and the diameter of the particle, in the question diameter of the particle d, since we are targeting this, so d is equal to 0.004 mm. So I am converting this into meter, so this will be 0.004 into 10 to the power of minus 3 meters. Okay, so this into 0.004 into 10 to the power of minus 3 whole square, d square, by 18 into mu is this much, 1 into 10 to the power of minus 3. So I will get a settling velocity value equal to 1.482 into 10 to the power of minus 5 meters per second. Okay, so since it is in meter per second, I am converting this into meter per minute. Okay, so convert this into meter per minute. 1.482 into 60 will be equal to meter per minute. Okay, now the time required, t will be equal to h by settling velocity. So this is a formula. Okay, time required formula. Since you might be getting a doubt how we got this, so settling velocity units is meter per seconds. Okay, so we are talking about height by time. Okay, so that's why it is time. So if I send this time, this is time, seconds is in times, we are talking about times, it's all about unit only. So if I send the time term here, so and the velocity term will come down, so this is meter term, so time term will be equal to h by velocity. That's how I am getting. So time will be equal to height. In the question, the height of the jar is given as, if you see here, height of the jar is given as 30 centimeter. So height is equal to 30 centimeter. If I convert it into meter, it will be 0.3 meter. So I am substituting here. So I will get time t equal to 0.3 by settling velocity is this 1.482 into 60. Okay, into 10 to the power of minus 5 should also come. So into 10 to the power of minus 5. Okay, so I will get time t equal to 337.38 minutes. So this I can write it as 300 minutes plus 37 minute 0.38 also, no? So this is in minute. Okay, but I want to convert this term into hours. That means I have to divide it by 60. Okay, so 60 minutes equal to 1 hour, no? That's why 60. So if I divide this 6 ones are 6 5s are, so I will get 5 hours 37 approximately 37 minutes. Okay, so if you see the answer options, option B is the correct option. Okay, so actually this is very tough question. In this video what I am doing is I am first preference I am giving to tough question which are like of very high standard. Okay, so that's why I am solving first tough problem. Okay, so you get a clear idea. Okay, this question is from this 19th question is from environmental engineering subject from filtration topic. Here in the question it is saying that there is a water treatment plant of capacity 1 meter cube per second and dimension of each filter is 6 meters by 10 meters. Okay, and the loading rate of filter is 120. Okay, so loading rate, or you can also say surface loading rate. Okay, and it is saying that when 2 of the filters are out of service for backwash, the surface loading rate at that time will be. Okay, so out for in this treatment plant, if 2 of the filters are not working, then what will be the surface loading rate? For that purpose, let us first we have to find out how many number of filter are there in this filtration plant. So this number of filtration will be depending upon the capacity. So let us first find out the number of filters. Okay, so here discharge will be equal to 1 meter cube per second. Since it is in terms of meter cube per second, let us convert it into meter cube per day. So this will be equal to 1 into 60, converting seconds into minutes, minutes to hours, hours to day. Okay, so this will be equal to meter cube per day. So if I solve this, calculate this value, I will be getting 86,400 meter cube per day. Okay, so this much meter cube per day of water capacity is there for this filtration plant. Okay, now the surface loading rate or loading rate is equal to 120. It is meter cube per day per meter square, so we can write it as meter per day also. Okay, now the total area require, total filtration area, sorry, I should say total filter area. So total filter area required is equal to Q by V naught. So Q is 86,400 by V naught is 120. So total filter area will be 720 meter square. Okay, Now number of filters will be equal to total area by area of each filter. Okay, so total area is 720 and area of each filter is 6 meter by 10 meter. Okay, area of each filter given in the question. So number of filters will be equal to 12. Okay, 12 number of filters will be required for this treatment plant for this capacity. Okay, so out of this 12, if 2 filter are not working, okay, so number of working filter are here is 10 then, if 2 are not working. Okay, so for 10 working filter, what will be the loading rate or surface loading rate? So loading rate for 10 number of filters will be equal to, so for before that, so let us first calculate the total filter area for 10 number of filters. Okay, so total area will be equal to 10 into 6 into 10. So this will be 600 meter square. Okay, this is area of each filter. So for 10 filter, this much of area is required. Okay, now we know that let us use this relation only. Okay, so total area is 600 is equal to Q by V naught. Okay, so we have to find out what is V naught here. For that purpose, V naught will be equal to Q by 600 total area. Okay, so Q is 86,400 by 600. So V naught will be equal to 144, okay, meter per day. So for 10 working filter, the surface loading rate will be 144. Okay, so out of given options, option A is our correct answer. Okay, now let us discuss question number 20. This question is also from environmental engineering subject from BOD topic. Here in the question, the BOD of 5 days of wastewater sample is 200 milligram per liter. Okay, so the value of the reaction constant K is given as 0.2 with base E. The ultimate BOD is, in the question he is asking what is the ultimate BOD. What is the ultimate BOD? Okay, this is actually, this type of question are very frequently asked. You can say this question is very important. This type of question has been asked in many exams, including GATE and IS also. Okay, so here BOD of 5 days at 20 degrees Celsius, we have a formula. BOD is equal to L0 minus E to 1 minus E to the power of minus KT. Okay, so this value is equal to 200 given in the question. So ultimate BOD we have to find out. 1 minus E to the power of minus K value is given as 0.2. So minus 0.2, and time here is this 5 is nothing but 5 days. Okay, so into 5. Okay, so if I solve this, okay, that is L0 is equal to 200 by 1 minus E power of minus 0.2 into 5. So I will get this value as 316 milligram per liter. Okay, So out of given option D is our correct answer. Okay, very simple but very important from exam point of view. Regularly it is been asked. Okay, now this question number 1, let us go according to the sequence. Till now we were solving the problems randomly, because I was solving those problems because as I said you earlier, those problems are like very tough. That's why I was doing that first. Now let us go in sequence. Now let us first solve the first problem. Here this question is from the estimation and costing subject. So here in the question it is saying that the method of measuring of concrete work specified cubic content shall be worked out to the nearest of 0.01 meter cube. Okay, so B is our correct answer. Now in this question number 2 is also from the estimation and costing subject. The excavation exceeding 1.5 meter in width as well as 10 meter square on plan but not exceeding 30 centimeter in depth shall be described as. So he is saying that they have done some excavation. So in width is 1.5. So this width is 1.5 like this, and this plan area, so this is 1.5 this width, and this whole area is 10 meter square it is saying, and this depth, so this depth it is saying, so this depth is 30 centimeter, that means 0.3 meter. Okay, so if the excavation is done somewhat like this, then that excavation should be called as, can be described as a surface excavation. So our option is surface excavation. Now if you see the question number 3, this is also from the estimation and costing subject. So in the Moss Hall diagram, the term halt represent, so the answer is A, sum of the product of each load by its distance. Here in this question number 4, it's an estimation and costing question. In the question it is saying that there is a foundation trench, okay, and in this trench a filling work is happening. We have to measure the filling here, okay, and this filling is done with a loose material. Okay, since we are using a loose material, after some time there will be a settlement. Okay, so suppose if you are filling the material up to this level, okay, after some time there will be a settlement and this level will come down to this level. Okay, so for that one we have to make deduction. So what percentage of deduction should be made means 25%. Okay, now coming to fifth question, it is also an estimation and costing subject question, and answer for this is D, 1 in 4. Okay, now question number 6 is also an estimation costing question, and answer for this is 1.5. Okay, here this question number 7 is also an estimation costing question. So this all are memory based questions only here, and in estimation and costing subject he is asking memory based question more here. Okay, and workout of quantity problem are also there, but compared to memory based question they are very less. Okay, so answer for seventh question is A here. Okay, and this 8th question is from the measurement of reinforcement bar. Okay, so here we have in the question it is saying that there is a cranked bar. It is cranked at both the ends like this. So this inclination is 30 degrees at both the ends. Okay, so suppose this depth is D here. Okay, this height, okay, this height is D here. For 30 degrees bend, okay, this in the question is asking what is this length. Okay, this length. So for 30 degrees bend, the length will be equal to 0.27 D, and for 45 degrees bend it will be 0.42 D, and for 60 degrees bend it will be 0.58 D. Since in the question he is saying that it is been cranked at both the ends, so we have to calculate this both the length. So that's why 2 into 0.27 D. So option B is our correct answer. Question number 9 is also from the estimation and costing subject. Here we have to work out the quantity. If you see the question, question say the number of cement bag required in making plain cement concrete flooring in an area 3 meters by 3 meters and thickness is 100 mm here, and the cement concrete mix is 1:3:6 here. So for in the question it is saying that there is a floor area like this. So this area is 3 meter by 3 meter and its thickness is 100 mm. So if I convert this 100 mm into meter, it will be 0.1 meter. Okay. So this is 0.1 meter here. So if I calculate work out the volume here, volume of this work, it will be 3 into 3 into 0.1. So I will be getting 0.9 meter. So for 0.9 meter cube of work for this given mixed condition, for this 1:3:6 cement concrete mix ratio, I have to work out the number of cement bag required here. Okay. So cement bag required, that means volume of the cement. Okay. First let us find out the volume of cement in terms of kg. Okay. So that I have to find out. Okay. So let us for a time being, let us forget this 0.9 meter cube of work. Let us consider 1 meter cube of work. Okay. For a time being. Okay. So for 1 meter cube of work and for this given mixed condition, let us calculate the volume of cement required. For that purpose, 1.5 divided by 1 plus 3 plus 6. Okay, these ratios. Okay, so why I am taking here 1.5? Why not 1? Means initially concrete, okay, when it is wet, its volume will be more compared to when it sets, okay, or get hard. So its volume will be more here. Okay, so after setting, its volume get reduces. So that's why we are taking here 50% more. We are taking into consideration. Okay, so if I calculate here this value, I will get it as 1.5 divided by 10 will be equal to 0.15 meter cube. So since here cement is 1, so if I so cement content will be equal to 1 into 0.15. So this will be 0.1. The cement content required here is 0.15 meter cube. Suppose he is asking volume of fine aggregate. Okay, so since here fine aggregate is 3 here, so it will be 3 into 0.15. So if you multiply whatever answer you get, that is the volume of fine aggregate here. So suppose he is asking volume of coarse aggregate. So coarse aggregate here is 6. So you have to multiply 6 into 0.15. Okay, like that we have to calculate. And this sort of question, the probability is high to ask this. What is the volume of fine aggregate, or else what is the volume of coarse aggregate? Chances are there that they may ask you. Okay, that's why I am telling here. Okay, but I have got the volume of cement here. Okay, so volume of cement required is this much here. Okay, so this is for the 1 meter. So for 1 meter cube. So for 0.9 meter cube, for 0.9 meter cube, cement content will be equal to 0.9 into 0.15. So for 0.9 meter cube of work, cement content will be equal to, cement required will be equal to 0.135 meter cube. So this much of volume of cement is required here, but I want the cement quantity in terms of kgs. Okay, so for that purpose we all know that unit weight is equal to weight by volume, or else density is equal to, okay, so that equation we can use it here. So the unit weight of cement is 1440. So weight we don't know, and the volume we have worked out here is this much. So it is 0.135. So I will get weight of cement equal to 1440 into 0.135. So this will be 194.4 kg. Okay, so this much weight of cement is required for this work. Okay, so but I want the answer in terms of bags, not in terms of kgs. So we know that one bag contain 50 kg of cement. So divide this answer by 50 here. So 1940, this value I can approximately take it as 200. Better to take 200 kgs. So 200 by 50, if you do it, the answer will be 4 here. Okay, so 4 bags of cement is required. So for this, answer is A. Now coming to question number 10th, it is a per 10 CPM subject question, and the answer here is C. Okay, and if you see the question number 11, it is also per 10 CPM question, and the answer for this is C here. It follow beta distribution. And for the question number 12, the answer is D here. Okay, so these three are the memory based questions only. Okay, going to question number 13. This question number 11, it is actually an IES question. Okay, this question was asked in 2001 question paper. Okay, for preparing for A, I would suggest you all to study all previous question papers of IES, then go to gate paper. Okay, gate paper study only 1 mark questions only. Okay, and here you study all IES questions. Okay, so most of the, you can expect most of the question from here on. Okay, if you see this paper, if you analyze, since I have analyzed this paper completely, I can say that most of the question have directly come. They have not even changed the data. They have directly copied and pasted here question. So it is to score good marks. You please refer this IES previous question papers. Okay, this question number 13 is from the building material subject. Okay, from the concrete chapter, and this is also an IES question. This question was asked in the year 1998. Okay, directly they have given the question. They have not even changed the value here. Okay, and if you see the question, in the question they are asking volume of the concrete to be mixed per batch here. Okay, so there is a 28S type of concrete mixer having a capacity of 0.8 meter cube. Okay, for mixing 1 meter cube of concrete, the quantity of cement required is 5.5 bags. Okay, in order to avoid frictional usage of the cement bag, the volume of concrete to be mixed per batch is asking. So initially we have to calculate the volume of concrete that has to be mixed per batch. For that purpose, okay, so for 1 meter cube of concrete require 5.5 bags of cement. So then for 0.8 meter cube of concrete, how much bags are required? Okay, so for that purpose 5.5 into 0.8 will be equal to 4.4 bags. So I cannot take directly as 4.4, so I will approximate this value to 5 bags. Okay, there won't be any such thing called like 4.4, 4.3 bags. We can understand 5.5 because it is half. 5.5 is nothing but half. We can understand that thing, but we can't take for 0.4, 0.3 like that. That's why I'm approximating this value to higher level. Okay. Now for 5 bags, of cement, the volume of concrete will be equal to 5 into 0.8 by 5.5. So this will be 0.73 meter cube of volume of concrete, okay, is required to mix per batch. Okay, so for answer is C here. Okay, this question number 14 is a structure analysis question. The question says the degree of static indeterminacy of a rigid jointed plane frame having 15 members, 3 reactions and 14 joint. Okay, so we have to find out the degree of indeterminacy, okay, for the rigid jointed plane frame. Okay, for this rigid jointed plane frame, the formula for calculating degree of indeterminacy is 3m plus r minus 3j. So here m is equal to 15, okay, and r is equal to 3 and j is equal to 14 here. Okay, so if I substitute this value, 3 into 15 plus 3 minus 3 into 14, so this will be 45 plus 3 minus 42. So answer will be 6 here. So option C is our correct answer. Here this question number 15 is a structure analysis subject question, and it is a influence line diagram chapter question. In the question it is saying that ILD for the force in the truss member is shown in the figure. Okay, if the uniformly distributed load of intensity 30 kN per meter longer than the span traverses, then the maximum compression in the member is. So this is a tension and this is a compression zone. So here maximum compression in the member will be. So for that purpose, if you see ILD diagram, it is somewhat like this. Okay, so if you see the length, here this ordinate is 0.58, so this length is 8 meters and this length is from here to here, this length is 4 meters and this length is also 4 meters and this ordinate is 0.29. Okay, so but I don't know what is this length. This length I don't know. Okay, so to find out this length, I am assuming this length as x. So since length from here to here is 4, okay, from here to here the length is 4 here, okay, 4 meter. So this length will be 4 minus x. So here this inclination, suppose inclination is theta here, so this also be theta. Using this geometrical property, I can say tan theta is equal to opposite by adjacent. So opposite here is 0.29 by x for this triangle. Okay, so for this triangle it will be opposite is 0.58 by 4 minus x here. So if I work out this whole thing, so it will be 0.29 into 4 minus x is equal to 0.58 x here. So this will be 1.16 minus 0.29 x is equal to 0.58 x. So x will be equal to 1.16. If I send this here, so and subtract it, I will get I will tell the directly this value only. So x value will be 0.29. So this value will be x value will be 1.33. So this x value is equal to 1.33 here. So this total length of this triangle, the total length of this triangle is 4 plus 1.33 here. So it will be 4 plus 1.33 here. Okay, now let us find out the area of this triangle. Okay, area of this triangle. So area of this triangle will be half into base is 4 plus 1.33, that is nothing but 5.33 into ordinate is 0.29. So this area is 0.77 here. Okay, to calculate the compression will be equal to 0.77 into UDL is 30 here. Okay, so compression is 23.186 here. So our option B is the correct answer here. And the question number 16 is from the airport topic. In the question he is asking us Air Force reference temperature here. They have given the average temperature and the mean maximum daily temperature also. Okay, so airport reference temperature will be equal to 2 times the average temperature plus mean maximum daily temperature by 3. So here in the question TA is equal to 30 degrees Celsius and TM is equal to, this is actually 45. Okay, this is 45, typing mistake. So this is 45 degrees. Okay, so airport reference temperature is equal to 2 into 30 plus 45 by 3. So this answer will be 35 degrees Celsius. So airport reference temperature is 35 degrees. Okay, so option B is our correct answer. Now in this question number 17 is again from the structure analysis subject, from influence line diagram topic, is and answer for this is all of the above. Okay, Muller bracing principle for influence line is applicable for continuous beam, frames, portal frames and fixed beam. Okay, so answer is all of the above. This question number 18 is a structure analysis subject question. In the question is asking degree of kinematic indeterminacy. Okay, degree of kinematic indeterminacy is nothing but degree of freedom only. So here at the support A, the degree of freedom will be 0 because it is a fixed support. Okay, whereas for this F it will be 1. Okay, since it is a hinge. Okay, for rigidly jointed here the degree of freedom will be 3 here, and at D also 3, here also 3, here also it will be 3 because they are rigidly jointed. Okay, so total degree of freedom will be equal to 0 plus 1 plus they are 3, 3, 3. So 4 into 3. So this will be equal to 13 here. Since in the question they are asking us to neglecting the axial strain, so we have to subtract the number of members here. So degree of kinematic indeterminacy will be equal to 13 minus number of members are here 1, 2, 3, 4, 5, 6. 6 members are there. So minus 6. So answer will be 7 here. So for this question, option D is the correct answer. For this question number 21, it's a environmental engineering question. Is asking septic tank is a settling tank and digestion tank. Okay, it is not a aeration tank. So option D is the correct answer. And in question number 22, okay, it is from the surveying subject from theoretical topic, and the here answer is D here, swinging. Okay, so and this is also very important question, short question but very important. Okay, so you can take it as a very important question here, question number 22. Okay, this question number 23 is also surveying subject question. From leveling they have asked this question. In the question it is saying that if the reduced level and the benchmark is 100 meters, the back side is this much and the foreside is this much, the RL of the forward station is. Okay, so for this one we can use the formula. Okay, sigma of backside minus sigma of forward size is equal to last RL minus first RL. Okay, so backward size reading are 1.215 minus foreside is this much 1.87. okay, and the last RL, since we have to find out a forward station RL, so this will be last RL minus the first RL will be this benchmark. Okay, so 100. So I will get a forward station RL value equal to this forward station RL value will be equal to minus 0.655. If I subtract this, I will get minus 0.655 plus 100. Okay, I am sending this value there. Okay, so this will be equal to 99.345 meters. Okay, so option A is our correct answer. Here question number 24 is also surveying subject question. This question is from the curve topic. In the question they are asking length of the long chord and mid ordinate they are asking. Okay, so length of the long chord L is equal to 2r sin theta by 2. So 2 into r here is 600 into sin theta is 60 here, so 60 by 2. So if I calculate this, I will get 600 as the answer. Okay, now mid ordinate will be equal to r minus root of r square minus L by 2 whole square. Okay, so here r is 600 minus root of 600 square minus this L value just now we have calculated. So this is 600 by 2 whole square. Okay, so if I calculate this, the mid ordinate will be equal to 80.4. okay, so the correct answer here is B. Okay, so this is length of the long chord and this is mid ordinate. Okay, here in this question, this is a fluid mechanics subject question. Okay, so in this question there is a venturi meter like this. Okay, so my venturi meter is like this. The diameter of this is 15 centimeter. Okay, and this throat diameter is 7.5 centimeter. Okay, so and discharge here is 30 liter per second. Okay, so if I convert it into meter cube, it will be 30 into 10 to the power of minus 3 meter cube per second. Okay, now in the question is asking coefficient of discharge here. Okay, now to find out the coefficient of discharge, okay, so let us first find out area of the throat, and so here D1 is equal to 15 centimeter. So if I convert it into meter, it will be 0.15 meter, and here D2 is equal to 7.5 centimeter. If I convert it into meter, it will be 0.075 meter. So similarly, A1 will be equal to pi by 4 into 0.15 whole square. This will be equal to 0.176, and A2 will be equal to pi by 4 into 0.075 square. So this answer will be equal to 4.41786 into 10 to the power of minus 3. Okay, so this is meter square, this is meter square. It is not important. Okay, so now the discharge through this venturi meter will be equal to CD into A1 A2 by root of A1 square minus A2 square into root of 2GH. Okay, so in the question this H value is given as this much. Okay, so discharge is 30 into 10 to the power of minus 3 equal to CD into A1 is this much, that is 0.176, into A2 is this much. Okay, 4.417 into 10 to the power of minus 3 by root of A1 square 0.176 whole square minus A2 square, so 4.417 into 10 to the power of minus 3 whole square. Okay, root into root of 2 into, okay, so 2 into 9.81 into H is 2.45. okay, under root. Okay, so if we calculate, if we simplify this, I will get a CD value equal to 0.95. okay, so option B is our correct answer. And this year in 2019 GATE, in one of the set, they have asked the question on this concept only. Okay, on this formula. Okay, here in this question number 26, it's a geotechnical question from the bearing capacity chapter. They have asked, and it is also an IES question, okay, and this came in the year 2011. Okay, they have not changed any value here, they have kept everything same. Okay, so this is a 2011 question. If you see the question, there are two footings. One is a circular footing, another one is a square footing. Okay, for this they are asking ratio of the ultimate bearing capacity. Okay, so ratio of ultimate bearing capacity of circular footing by ultimate bearing capacity of square footing they are asking. Okay, so let us first consider the circular footing. Okay, for circular footing, the ultimate bearing capacity will be equal to 1.3 C NC plus gamma D into NQ plus 0.3 gamma B N gamma. Okay, since in the question they are saying it's a cohesionless soil, so C will be equal to 0, and they have also seen that these two footing are founded on the surface. That means this depth of foundation is 0 here. So this thing is 0 and this D is 0. So this whole term will be 0 here. Okay, so what I am left out is this only. Okay, so I am left out with this. So ultimate bearing capacity for circular footing will be equal to 0.3 gamma B into N gamma. Okay, now coming to the square footing, the ultimate bearing capacity formula is 1.3 C NC plus gamma D NQ plus 0.4 gamma B N gamma. Okay, so here also this whole term will be 0 and this will also be 0. Okay, since the properties are same for both circular and for square. Okay, so what I am left out here is 0.4 gamma B N gamma. In the question, it is also saying that the diameter of a circular footing is same as the side of the square footing. So this B, and here B is nothing but diameter for the circular footing, and this B is nothing but side for this square footing. So in the question it is saying that B of circular is equal to B of square. Okay, so this ratio, this ratio, that is ultimate bearing capacity of circular and ultimate bearing capacity of square will be equal to 0.3 gamma B N gamma by 0.4 gamma B N gamma. So this whole thing will get cancelled. We will be left out by 0.3 by 0.4. So this will be equal to 3 by 4. So option A is our correct answer. Here this question number 27 is from the building material subject. Okay, from timber topic they have asked. In the question it is asking that in tree the cambium layer is situated between. Okay, for this answer is B. It will be situated between inner bark and the sapwood. If you see this diagram, okay, so this is the inner bark. Okay, so this is the inner bark. Okay, and this is the outer bark. Okay, so and this is the sapwood. Okay, this is the sapwood. So this is a sapwood. Okay, so here we have a cambium layer. Okay, and this is the pit here, and this is the hardwood. Okay, sometime in the question they ask where will be the pit, so it will be at the center here. Okay, and they will also ask hardwood, about location of the hardwood also they will ask. okay, and the location of the sapwood. Okay, so where is the location of the sapwood means it will be between the hardwood and the cambium layer, we can say. Okay, so where will be the hardwood if we ask? So it will be between the pit and the sapwood, we can say. So like that they can ask in the question. Okay, here in this question number 28, it is actually from the strength of material subject, from shear force and bending moment topic, but this question has been framed wrongly. In this question they are asking fix and moment. Okay, it shouldn't be fix and moment, it should be moment at support A. Okay, this fix and should not be taken. Okay, it should be moment at the support A if you are saying. Okay, they should ask like this, because this question is a reference from IES question only. Okay, so if you see IES 2014 question, in that question they have given the figures same only. Okay, only the intensity of load they have changed, and this direction of the load, okay, this inclination is not there, it is actually a vertical load in this IES question. Okay, so it should not be there. Since they have given this question, if we are asked to find out bending moment at A, okay, so I have to take the vertical component of this inclination load. Okay, if I am taking the vertical component here, okay, so this vertical component will be equal to 10 sine 45. Okay, so 10 sine 45 will be equal to 10 by root 2. Okay, so this here the vertical component of this load is 10 by root 2. Okay, so here at A the moment at A will be 10 by root 2, and this distance from here to here, this distance is 1 meter. So into 1, so moment at A will be 10 by root 2. Actually this should be the answer. So this question has been framed wrongly, and in the key also they have given the answer as A. So if we want to get this answer, so this 10 by root 2 should be multiplied by 2, then only we will get the answer as 14.4 kilonewton per meter. So this answer is also given wrong. Okay, so actually the correct question should be like this. Okay, so this question has been framed wrong. Okay, this question number 29 is a RCC subject question. In the question is asking us limiting depth of neutral axis for Fe 550 grade steel. If you see the code, IS 456 2000, in this code they have given the limiting depth of neutral axis, that is XU max value for 250 grade steel, for 415 and for 500 grade. They have, for this 3 grade of steel they have given the value of this XU max, but for 550 grade they have not given. Okay, if you see the code for this 250 grade steel, XU max value is 0.53D, and for 415 it is 0.48D, and for 500 it is 0.46D. Okay, now we have to find out 550 grade steel how much. Okay, now for that purpose we have to take the stress block diagram here. Okay, we have to derive it. Okay, suppose this is my beam. Okay, this is my RCC beam, it has been reinforced here. Okay, there is a neutral axis like this. Okay, so from here to here it will be the effective depth. Sometimes for simply asking, though it is it is a simple question, they will ask what is the effective depth. So effective depth is nothing but from the center of the bar to extreme compression fiber. Okay, so this distance, the distance from the extreme compression fiber to the center of the bar is the effective depth. Okay, so this is the beam, it's having a width B here. Okay, now if I take the strain diagram, okay, so strain diagram will be somewhat, it will be like this. Okay, so here at this point the strain will be 0.0035, and here at the tension zone the strain will be 0.002 plus 0.87 Fy by Es. Okay, so if I substitute the value of Fy, that is 550, in this equation, I will get the answer as 0.0043. Okay, now since here there will be an inclination theta and here also there will be an inclination theta. Okay, if I take the geometrical property into consideration, so tan theta will be equal to opposite is 0.0035 by adjacent, so this is xu max. Okay, and this depth will be equal to, okay, this depth will be equal to d minus xu max. Sorry, I should have told you this in the beginning. Okay, while drawing this figure only I should have told. Okay, so this, so tan theta is equal to opposite by adjacent, adjacent is xu max. Okay, so this will be equal to, now this bottom triangle I should take, opposite is nothing but this value. Okay, this value is this much. Okay, 0.0043 by adjacent is this much. Okay, that is d minus xu max. Okay, now if I simplify this, term, that is 0.0035 into d minus xu max will be equal to 0.0043. I'm sending this term here and this term here, into xu max. Now if I simplify this, okay, if I simplify this, I'm not doing simplification here, I will get xu max value equal to 0.44d. Okay, so option D is our correct answer. Why I am deriving this is because in the code they have not given the value of 550, that's why I am doing here. So even to get the value for 250, if you follow the similar procedure, you will get this answer. So here in place of Fi, if you directly substitute this value, okay, here, and do this procedure, this whole procedure if you are doing, so you will get this value only. Okay, so this question number 30 is from the pertain CPM topic only. In the question they are asking us to find out the expected time. Okay, so for this the formula is T naught most optimistic time plus 4 into most likely time plus TP by 4. Here the most optimistic time is given as 4 days, most likely time TL is given as 11 days, and TP is given as 12 days. Okay, if I substitute this value, so the expected time will be equal to 4 plus 4 into 11 plus 12 by 4. So this will be equal to 10 days. So option B is our correct answer. Okay, this is a very important question. Okay, this type of question you can expect, definitely you can expect, and this is previous IES question. Okay, in the year 2097 they have asked this question. They have not even changed this numerical values, exactly they have given here. So it is the same, it's a copy paste question, I can say directly. Okay, here this question number 31 is also a RCC subject question. Here asking whether the beam is a singly reinforced, doubly reinforced or not, they are asking. Okay, for that purpose we have to first calculate mu limit here. Okay, for actually if you see the question, in the question it is saying that there is a beam, there is a rectangular beam like this, and the width of this beam is 300 and the effective depth, and its effective depth is 400. Okay, and M20 grade concrete is used here, and the grade of this steel is 415, and the area of steel they have not given. Okay, so for this property, okay, for this M20 and 415, and for this dimension we have to find out the limiting moment of mu limit we have to find out here. Okay, for the Fe415 grade steel, the mu limit will be equal to 0.138 FCK BD square. Okay, so mu limit will be equal to 0.138 into 20 into B value is 300 into D is 400 square. So this value will be equal to 132.48 into 10 to the power of 6 Newton meter. If I convert it into kilonewton meter, it will be 132.48 kilonewton meter. So this is mu limit value. Okay, so in the question mu value, okay, the beam is subjected to this much of movement. Okay, so this beam is subjected to 150 kilonewton movement, but for the M20 grade concrete and Fe415, for the strength that we have provided to beam, it can only resist this much of bending moment, but this beam is subjected to this much of movement, so it is subjected to more movement. So that's why we cannot take a singly reinforced beam here, we have to go for the doubly reinforced beam. Okay, so if mu is greater than mu limit, then we have to go for the doubly reinforced beam. Okay, or else simply I can say that whenever the beam is experiencing more bending moment than its capacity, then we have to go for the doubly reinforced beam. This question is from the RCC. Here it says, according to the code, the minimum grade of concrete required when the water cement ratio is 0.5 and the minimum cement content is 300 kg per meter cube. Okay, if the minimum cement content is 300 kg and the water cement ratio is 0.5, then what will be the minimum grade of concrete? Okay, if we see the table 5 of IS 456 2000 code, okay, if you see here we have a minimum cement content 300 here. Okay, and there is a water cement ratio of 0.5. For this, the minimum grade of concrete should be M25. So from the given option C is our correct answer. For question number 33, option A is the correct answer, and this 34 is actually not a technical question, it's a current affair question. Okay, but still for your reference, the correct answer is A here. Okay, this question is from the steel subject from connection chapter. If you see the question, it says according to the code, the nominal shear capacity of M20 bolt of grade 4.6 with one shear plane passes through the bolt shank and another passes through the threaded portion. Okay, so in the question it is asking what will be the nominal shear capacity. Okay, in the question it is asking nominal shear capacity will be what. Okay, and in the question it is saying that one shear plane passes through the bolt shank and another through threaded. Okay, that means suppose let us consider a double cover butt joint. Okay, so there is a pull here, let us say P by 2. So the P by 2, here there is a P force is pulling here. So we are connecting through a bolt here. Okay, so there is a bolt like this. Okay, so till at this shear there are two shear plane, one is here, another one is here. Okay, so at this there is a only shank here. Okay, at this shear plane there is only shank, but at this here there is a thread, so threading is there like this. Okay, so here N is equal to 1 comma ns is equal to 1. Okay, this is with the thread intersection and this is with the shank. Okay, now in the question it is asking us to find out the nominal shear capacity. Okay, now the formula for nominal shear capacity according to code is FUB by root 3 into NN ANB plus NS ASB. Okay, now the nominal shank area of the bolt A and B will be equal to ASB. Nominal shank area of the bolt will be equal to pi by 4 into 20 square. So this will be equal to 314.159. Okay, so net tensile area of the area at the thread, that is A and B, net tensile area at the thread will be equal to 0.78 times the ASB. So 0.78 into 314.159. So this will be equal to 245.04. Okay, now since the grade of bolt is 4.6, so FUB will be equal to 400 Newton per mm square. Okay, so if I substitute all this value in this equation, okay, so VNSB is equal to FUB is 400 by root 3 into 1 into A and B is this much, 4 plus 1 into ASB is this much, okay. If I calculate this, I will get the answer as 129.14 kilonewtons. Okay, so from the given option D is our correct answer. Okay. Now if we see question number 36, okay, this is also from the steel from compression member. Here they are asking the slenderness ratio of a lacing bar in build-up steel compression member shall not be less than, okay, according to code, okay, it is 45. Okay, the slenderness ratio should not be less than 45. So for 1 mark, okay, for this type of exam, this type of questions are very important. Okay, so you can study the slenderness ratio and effective length, all those things. Okay, what should be minimum thickness of the lacing bar. Okay, so and what should be the angle of inclination of the lacing bar with the longitudinal axis. Okay, all these things you have to remember. And also the lacing should be like what should be the transverse shear carried by the lacing, okay, from the direct axial column. Okay, for all these things are important from objective point of view. Okay, again this is also from the steel subject. Here the answer is short column A. Okay, and this question is from strength of material from deflection chapter. Okay, here they are talking about the conjugate beam method. Okay, so in the question it is saying if fixed support in actual beam is considered as dash support in conjugate beam. Okay, so let us take, this is actual beam, and here let us take conjugate beam. Okay, here in actual beam, if we are having a fixed support, okay, so in conjugate beam this fixed support will become free end, and this free end will become fixed in conjugate beam. Okay, now in actual, if actual beam is say like this, hinge at one end, free end at other end, so in conjugate beam this hinged will remain hinged. Okay, so this hinged will remain hinged and this free end will become fixed here. Okay, so suppose if you are having a beam somewhat like this, hinged and roller here, so in conjugate beam this will be same, roller will remain roller and hinged will remain hinge. Okay, suppose in actual beam we are having say fixed beam like this, so in conjugate beam it will be having like this. Okay, there won't be any support at this end and at this end. Okay, in conjugate beam, okay, stability is not required. Okay, this is actually a assumption, the hypothetical beam this is. Okay, so stability is not required here. Okay, and in one more thing, in actual beam, suppose we are having a hinged like this here, so in a conjugate beam this will become a internal hinged here. Okay, internal hinged here. Suppose we are having a say fixed here and internal hinge is there, so this will be like this. Okay, suppose here we are having internal hinge, then here we will get a external hinge here. Okay, so these are the conversions for this. Okay, so very important. Okay, very simple and very important here. Okay, and one more thing, coming to the loading. Okay, in conjugate beam, in actual beam, slope will be equal to shear force in conjugate beam. Okay, if you take a conjugate beam and if you find out the slope, that slope value will be equal to, sorry, if you find out shear force in conjugate beam, this shear force value will be equal to slope in actual beam. Okay, and in conjugate beam, if you are finding out in bending moment, this bending moment will be actually equal to the deflection in actual beam. Okay, so it is very simple. Okay, so this short question, chances are there that they can ask in exam. Okay, that's why I am just describing this conjugate beam method. So this is a very little concept here. Okay, again this is a RCC question. In the question it says a rectangular beam of 300 meter width and 500 mm, actually 300 mm width and 500 mm effective depth has a tensile reinforcement of 1346 mm square. The beam M is constructed using M20 grade concrete and Fe415 steel. Calculate the neutral axis. So he is asking depth of neutral axis is equal to what? Okay, and in the question it has given AST equal to 1346 mm square. Okay, and width is equal to 300 mm and effective depth is equal to 500 mm. Okay, and FCK is equal to 20 megapascal and Fy is equal to 415 megapascal or Newton per mm square. To find out depth of neutral axis, okay, assuming that it is a balanced section, compression is equal to tension, so 0.36 FCK D into XU is equal to 0.87 Fy AST. Okay, so from this XU will be equal to 0.87 Fy AST by 0.36 FCK B. Okay, so 0.87 into Fy is 415 into AST is 1346 by 0.36 into FCK is 20 and B is 300 here. So if you calculate this, I will get depth of neutral axis has 224.98 mm. So this can be approximated to 225 mm. So option A is our correct answer. Okay, and for the, and this is from the pre-stress concrete topic. Okay, so for this question number 41, option A is the correct answer. Okay, this method is used in pre-tensioning and all these methods are used in post-tensioning. Okay, here in this question it is asking polar moment of inertia for circular section. So this question is from strength of material from torsion topic. Okay, so polar moment of inertia, that is IP, or else I can also write it as IZZ, but in this question it is saying IP, so let us take IP only here. Okay, so IP will be equal to IXX plus IYY. Okay, so for circular section IXX will be equal to IYY will be equal to, this is moment of inertia, pi by 64 into d to the power of 4. Okay, so polar moment of inertia will be equal to pi by 64 into d to the power of 4 plus pi by 64 into d to the power of 4. So this will be equal to 2 into pi by 64 into d to the power of 4. 2 1s are 2 32s are. So IP will be equal to pi by 32 into d to the power of 4. Okay, so this is my required answer. So option A is the correct answer. This question number 43 is from the irrigation subject from water requirement of crop topic. Okay, so here in this question it is saying that the gross commanded area for distributor is 6,000 hectares. Okay, 80% of which is cultivable, irrigatable. The intensity of irrigation for Kharif season is 25%. The area to be irrigated in Kharif season is. So he is asking, out of this 36,000, only 80% is cultivable, can be used for cultivation. Okay, so out of this, so let us first 6,000 hectare is there. Out of this only 80% can be cultivated. So 80% means 0.8. So this I will get it as 4,800 hectare can be cultivated. Out of this 4,800 hectares, only 25% of the land is used in the Kharif season. Okay, so intensity of irrigation for the Kharif season is 25%. So this out of this 4,800 into 25% means 0.25. So if I multiply this, I will get 1,200 hectares. Okay, so 1,200 hectare area to be irrigated in the Kharif season. Okay, so option B is my correct answer. This is very simple. I hope you understand. Okay, not to get confused here. Okay. Okay. Now coming to question number 44. Here option A is the correct answer. This is a memory based question. Okay, very simple. This question number 44. This question is from the design of bridge topic. Okay, this sort of tough questions comes in examination. Okay, but you need not answer this question. Okay, you can leave it, but still the answer for this question is B here. Only to make you not score full marks, this sort of questions will be setting in the exam. Okay, it's even 46 you can't answer this question. Okay, so answer for this 46 is D here. Okay, and for 47 answer is A. This is from the pre-stress concrete topic. Okay, now coming to question number 48. Okay, so here in the question it is saying that the pH of the water at incoming is 7.3. Okay, so this is, I will say this is pH I, and pH of the water at outgoing is 8.5. so I will say this is P outgoing, so out. So in the question they have given this pH of incoming and pH of outgoing. So in the question they are asking what is the average pH of the water assuming linear variation of pH with time. Okay, now since this pH of incoming is this much, so H plus ion of this incoming will be equal to 10 to the power of minus 7.3, and pH ion of outgoing will be equal to 10 to the power of 8.5. Okay, now let us take the average of this. So average H plus ion average will be equal to 10 to the power of minus 7.3 plus 10 to the power of minus 8.5 by 2. So answer for this will be equal to 2.664 into 10 to the power of minus 8. Okay, now pH average will be equal to log base 10 1 by H plus ion average. Okay, so this will be equal to log base 10 into 1 by 2.664 into 10 to the power of minus 8. Okay, this is, so if you do this you will get P average pH value and this will be equal to 7.57. So option B is the correct answer. Okay. Here this question is from the environmental engineering subject from filtration topic. In the question it is saying that a city has a population of this much, and the average they have given the per capita demand, okay, as 160 liter, okay, 160 liter per day. Okay, so what is the actual number of filter required if size of each filter is this much? Okay, assuming the rate of filtration has this much. Okay, so in the question they have given us the population and per capita demand, okay, and asking us to find out number of filter required. Okay, so let us first calculate the discharge here. So discharge will be equal to population into per capita demand. So population is 1 lakh, okay, and per capita demand is 160 liter per day. Okay, so discharge will be equal to 16 into 10 to the power of 6 liter per day. So since it is in liter, I am converting into meter cube. So this will be equal to 16 into 10 to the power of 3 meter cube per day. Okay, now in the question the rate of filtration is given as assuming the average filtration rate. So this is nothing but the rate of filtration is given as 4500 liter per hour per meter square. Okay, so this is given per hour, but I will convert this into let us first convert this is given in liters. Okay, so I will convert it into meter cube. So this will be equal to 4.5. Initially we have to divide it by 1000. So this liter will be converted into meter cube. So I am dividing by 1000 here. So I will get 4.5 meter cube per hour per meter square. So I want to change this hour into day. So what I have to do is 4.5 by 24. Okay, in a day we have 24 hours, but that's why dividing it by 24. So this will be equal to meter cube per day per meter square. So rate of filtration, finally I will get a rate of filtration equal to 4.5 by 24 into meter cube per day per meter square. Okay, now the size of each filter is 9 meter by 5 meter. So area of each filter is equal to 9 into 5. So this will be 45 meter square. Okay, now the total area of filter required will be equal to discharge by rate of filtration. Okay, so discharge is 16 into 10 to the power of meter cube by rate of filtration is this much. Okay, the rate of filtration, finally we got this much. So this is 4.5 by 24. So total area I will get it as 148.14 meter square. Okay, so number of filters, so number of filters will be equal to total area by area of each filter. Okay, so total area is this much, that is 148.14. Area of each filter is 45 divided by 45. So number of filters will be equal to 3.29. So I will approximate this value to 4 number of filters. Okay, so option C is the correct answer. Okay, this question is from environmental engineering subject from BOD chapter. In the question it is saying, it has given the initial BOD. Okay, so initial BOD is this much and the final BOD is this much. Okay, and they are asking us to find out the BOD at 5 days at 20 degrees temperature is how much. Okay, for this we have a formula. BOD at 5 days at 20 degrees temperature will be equal to initial DO minus final DO into dilution factor. Initial DO is 5, final DO is 4, and the dilution factor will be equal to 100 by 1 because 1% dilution sample. Okay, so this will be equal to 100 here. So if I substitute everything here, okay, so BOD 5 days at 20 degrees Celsius will be equal to 5 minus 4 into 100. So this will be equal to 1 into 100 is equal to 100 milligram per liter. So option B is our correct answer. Okay, here this question is from the surveying chapter, from the compass surveying topic. In this question they have given the reduced bearing, okay, and asking us to find out the whole circle bearing. Okay, so reduced bearing is not 45 degrees east. So if I take, so this is north, this is east, this is south, and this is west here. So here we have this bearing has 45 degrees. Okay, and in whole circle bearing this value will be 45 only. Okay, because in what happen is in whole circle bearing we won't be having any north south. Okay, we will be measuring the angle in in clockwise direction. Okay, suppose there is a bearing here. Suppose I am telling, it is not related to this problem. If there is if we want to measure this angle, okay, so we have to take this whole thing. Okay, actually there are few formulas for this conversion. Suppose if you want to convert whole circle bearing to reduced bearing, okay, suppose your inclination is between 0 to 90 in the whole circle bearing, it comes okay, if your inclination theta, okay, is between this 0 to 90, then in reduced bearing it will be north theta east. Okay, so I hope you are aware of this whole formulas. I need not tell here, but what I want to say here is, instead of memorizing all these formulas for conversion, it is better to understand the concept here. Okay, so let us first see in what happens in whole circle bearing. Okay, as I said you, in whole circle bearing, okay, wherever your inclination might be, okay, it might be in the first coordinate, second coordinate, or fourth coordinate, you will be measuring it in a clockwise direction only. Okay, this is like, okay, this is very simple. But in reduced bearing, what happen is, suppose if your inclination is between north and east, you will be measuring with respect to north only here. Okay, suppose if your inclination is say here, so you will be measuring it with reference to not only here. Okay, so suppose your inclination is say here. Here you will be measuring it with reference to south here. Okay, suppose here your inclination is there, so here you will be measuring it with respect to south only here. Okay, so if you want to denote say this inclination, so this inclination is theta here, so if you want to denote it, you will be denoting as south theta west. Okay, so because you are measuring it with reference to south, so south will come first. Okay, so for reference either you can take north or you have to take south. Okay, you cannot take east and west here, only north and south can be taken. Okay, so with reference to south only you have to take, or else with the north. Okay, so that's why. So wherever you are taking, whatever the reference you are taking, you have to mention it first here. Suppose if you are taking the reference as north, you have to mention north, then theta, then east or west. Okay, if it is here, you have to take it as east. If it is here, you have to take it as west. Okay, very simple concept. Okay, I hope you are understanding here. Okay, let us solve one or two example here. Suppose there is a inclination here. Okay, and this is north, this is east here. Okay, sorry, west here. Okay, so for this you will be measuring it with reference to north only, theta, and you will write it as north theta west. Okay, so what happens is, if you want to convert this into whole circle bearing, what you have to do is you have to, okay, you have to measure the angle right from here. You have to measure it here. Okay, so what you can do is, to convert it, you have to subtract 360 degrees minus theta, then you will get this inclination. Okay, like that. Suppose if in reduced bearing, if your inclination is say here, for this you will be measuring, this is south, this is north, this is east, this is west. So you will be measuring it here, and you will be, this inclination is theta, you will be denoting it as south theta west. Okay, since you are measuring it from the south, you are taking reference from the south, you are mentioning it first. Okay, suppose it is here. Okay, you will be measuring from here. Okay, this theta, and you will be denoting this thing as south theta east. Okay, suppose if you want to convert this inclination into whole circle bearing, okay, you have to measure it from here clockwise. Okay, simple as that. Okay, so this will be, okay, very simple here. Okay, like that. I hope you have understood here. Okay, here this question is also from surveying. In this question it is saying, keeping the instrument height has a 1.5 meter, length of the staff has 4 meter, the slope of the ground has 1 in 10. The side on the downstream slope must be less than dash. Okay, so in the question it is saying that there is a instrument, like this, and its height is 1.5 meter. Okay, and this, there is a ground profile is like this, there is a slope, and this slope is a 1, this slope is 1 in 10. That means for every 10 meter, okay, for every 10 meter there will be a 1 meter reduction. Okay, so suppose this inclination is theta here. Okay, I will tell you later. So in the, so it is like this, ground profile is like this, and they have kept the staff, okay, and the length of this staff is 4 meter. So they have kept a staff here like this. Okay, so they have kept a staff like this here, and they have cited here. So this length is 4 meters here. So in the question they are asking what will be this distance. They are asking this distance x. So x is equal to what they are asking. So I can tell that okay, this distance. Okay, so this length is equal to this side length only. Okay, so I have to find out the value of x here. So this is inclination theta here. Okay, so from this figure, okay, so I can tell that tan theta is equal to 1 by 10, right? And from this I can tell that so this height will be equal to this height will be equal to 4 minus 1.5. So this will be 2.5. So this height is 1.5 here. Okay, this height is 1.5 here, and the total length and this total length is 4 meter here. Okay, from this I can say this angle will be same only. Okay, because I'm talking this slope only, we are taking this slope. Okay, so tan theta will be equal to 2.5 by x. Okay, so this will be equal to 2.5 by x. Okay, if I take this x will be equal to 2.5 into 10. So this will be 25 meter. So this length is 25 meters. So option C is our correct answer. For this question number 53, okay, so answer for question number 53 is B. Okay, it is a memory based question, and for this question number 54 is a transportation engineering. It is from the transportation engineering subject. Okay, and he is asking, if you see the question, for mixed traffic condition, the rate of super elevation for horizontal highway curve of radius 500 meter and speed of 100 kmph is. So super elevation is asking. Okay, for mixed traffic condition, E will be equal to V square by 225 R. Okay, so if I substitute, V is 100 square by 225 into R is 500. So E value will be equal to 0.088. Okay, so from the given option B matches. Okay, so correct answer is B here. Okay, here this question is from geotechnical subject, from earth and pressure chapter. Okay, for this the ratio of sigma H by sigma V will be equal to coefficient of lateral earth and pressure. Okay, now this question 56 is from per 10 CPM only, and the answer is event, C event, and 57 is also from the per 10 CPM. The answer here is A. Friends, I want to just remind you that in this question paper, what I have observed is he has asked more number of questions from estimation and costing and from CPM and PERT. Okay, for these two subjects he has given maximum importance. So please keep this in mind. Okay, while preparing, give importance to this subject. Okay, here this question number 58, actually in the, it is a estimation and costing. subject question. Okay, here he has it is given from the earthenwork chapter, but this question, in this question data is incomplete, so we have to ignore here. And if you come to question number 59, it is from the geotechnical subject, from the classification of soil. Okay, here the answer here is B. Okay, because if coefficient of uniformity in this question is given as 8, if coefficient of uniform coefficient is greater than 6, then it will be well graded sand. Okay, and if I calculate plasticity index, that is liquid limit minus plastic limit, so I will get 38 minus 34.2. I will get this answer as 3.8, which is less than 4. So if it is less than 4, it will be silty sand. So option B matches our answer. Okay, and coming to question number 60, this is answer is B here. Okay, here this question number 61 is from the geotechnical chapter, from the shear strength topic, geotechnical subject, from shear strength topic. And answer for this is C, sensitivity. Sensitivity is nothing but a ratio of undisturbed sample of soil by remolded sample of soil. Okay, and 62 we have already solved, and 63 the answer here is 3. Okay, why are bricks soaked in water before use in brick masonry? Okay, to prevent the depletion of moisture. Okay, from the actually it should be from the cement mortar. Okay, it should not be from the water. Actually this is IES question. Okay, from IES they have taken reference from IES or else engineering service. Okay, and coming to question number 64, here it impact assessment question. It is environmental impact assessment. So for this option D is the correct answer. Okay, so this is a simple and like a memory based question. Okay, again this question is from the strengthometer, from torsion topic. Okay, so answer B is the correct answer. Okay, so coming to 66, this is from the answer A is the correct answer here. Okay, here this question is also from strengthometer topic. Okay, from columns chapter he has asked. He is asking us what will be the buckling load formula here. So answer is A here, pi square EI by L square, where L is the effective length. Okay, so this effective length changes for different end condition. Suppose we have a column like this, and here it is fixed at both the ends. So effective length will be equal to actual length by 2. Suppose this actual length is L here, so effective length will be equal to actual length by 2. So what is the effective length? Effective length is nothing but distance between this distance where the bending moment is becoming 0. So this is the effective length. Okay, this is the effective length. Okay, now for suppose if we are having one end fixed and another end hinged, for this end condition effective length will be equal to L by root 2. Okay, and if we are having one end fixed and other end free, so effective length will be equal to 2L. Suppose if we are having both the end hinged like this, then effective length will be equal to actual length. So these values you have to substitute here. So we will be getting the buckling load. Okay, the Euler buckling load we will be getting here. Okay, this end conditions why I am saying are is chances are there that they may ask you the effective length for this 4 conditions. Okay, this question is from fluid mechanics subject from pump topic. In the question it is saying that for a discharge Q, the specific speed of the pump is ns. For half discharge with the same head, the specific speed will be. Okay, so we know that specific speed for pump is equal to n root q by h to the power of 3 by 4. From this relation, I can say that specific speed is proportional to root q. Okay, so if q1 initial discharge is equal to q and later this discharge is q by 2. Okay, half the discharge he is saying. So from this relation I can tell that ns1 by ns2 will be equal to root of q1 by root of q2. Okay, I can tell it like this. So or else ns2 by ns1, let us say, it will be easy to simplify here. So this will be, or else I can tell you again. Okay, so specific speed of 2 by specific speed of 1 will be equal to root q2 by root of q1. Okay, so this implies specific speed of 2 will be equal to q2 is root of q by 2 and q1 is root q into ns1. So ns1 is nothing but ns, let us assume, so need not write here 1. Okay, so ns2 will be equal to root 2 will get root q will get cancelled. This actually I can write it as root q by root 2 also. So root q will get cancelled. So I will be left out with ns by root 2. So answer is this. Okay, so actually here it should be ns by root 2. Then option B would have been the correct answer. Okay. Coming to question number 69, it is an environmental subject question. This question is from the quality of water topic. In the question it is asking temporary hardness in water is caused by, option A is the correct answer. Temporary hardness is caused by carbonate. It is caused by carbonate and bicarbonate of calcium and magnesium, and permanent hardness is caused by sulfate, chloride and nitrate of calcium and magnesium. Okay, so this is actually a IES question. Okay, very important. This question is very important. Okay, now coming to question number 7. Okay, so option B is the correct answer. Okay, and for the question number 71, option C is the correct answer. For question number 72, option A is the correct answer. Okay, and this question, for question number 73, again this is for super elevation. We have already done this problem in this video, so option C is the correct answer. Okay, and for question number 74, they are asking volumetric strain is nothing but change in volume by original volume. So option A is the correct answer. For question number 73, they are asking maximum deflection for a cantilever beam carrying a load of W at the free end. Okay, there is a cantilever beam and there is a load W here, and its length is L. Okay, this load is W here. Okay, so deflection will be WL cube by 3EI. Okay, now for this level, this level of exam, to be frank, for this level of exam, from deflection topic, you don't go deep. Okay, just learn the slope formula and deflection formula for cantilever beam carrying point load and UDL. Okay, UDL and UVL. Okay, for the cantilever beam. Coming to the simply supported beam, you just learn the formula for slope and deflection for point load and for the UDL. Okay, and for uniformly varying load. Okay, or to be on safe side, if you are learning these formulas, okay, that is slope formulas and deflection formulas for this condition, this 6 condition, it will be like you will be on the safe side. Okay, asking beyond this means the paper setter want to set the paper very tough from this topic only. Okay, if you want to set the paper average or easy, then he will ask it from here only. Okay, now coming to question number 76, answer is which of the following condition require geometric survey. Okay, normally we will be doing geometric survey for the large area. Okay, so survey of country means we are doing survey of a large area. So option B is the correct answer. Okay, now for question number 77, it's a building material question. Okay, answer is D here. Okay, this question number 73 is also from the building material. Okay, from the cement chapter. Most commonly used admixture for accelerate the setting time. Okay, the answer is calcium chloride. Okay, if you want to retard the setting time, then answer would be gypsum. Okay, these two are the very famous and questions like they are asking very repetitive in every exam. Okay, whether it is SSC, JE or even IES exam, they will be asking about gypsum and calcium chloride, that is accelerator and retarder. Okay, so very important, very important. Okay, remember it. Okay, now coming to question number 79. Okay, here is this question number 79 is from the brick topic from the building material subject. Type of bond in which every other course contain both header and shoulder is called. The answer would be for this 79 is Flemish bond. Okay, so if you see this Flemish bond, there is a stretcher and then there is a header here. So alternative course of stretcher and header in a same row is known as Flemish bond. Whereas in the English bond, in a row there will be completely stretcher. Okay, then the above row will be containing header. Okay, after that there will be a stretcher. So this is a English bond. Okay, and another question which you can expect this from this bond topic is which type of bond will be able to carry the maximum load, which bond will be having the maximum load carrying capacity. Okay, the answer would be English bond. English bond has the maximum load carrying capacity. Okay, so for this 79, B is the correct answer. Okay, this question is from the geotechnical subject from consolidation topic, and answer here is C. Okay, now coming to question number 81, this is from the irrigation subject from dam topic. Okay, option A is the correct answer. Okay, for no tension, okay, base width B will be equal to H by root of g minus k. Okay, and for no sliding, okay, for no sliding, base width b will be equal to h by mu into g minus k. Okay, so there are chances that they can ask this formula also. That's why I'm telling you. Okay, so option A is the correct answer for 81. Here, this question number 82 is from the building material topic from the brick chapter. First class brick should not absorb 20% of the water. Okay, 20% is the correct answer. So if you see the question, a first class brick when immersed in cold water for 24 hours should not absorb water more than 20% of its dry weight. Okay, remember this, they can ask this also. 20% of the dry weight. Okay, so they will give saturated weight and all those things they will use. So answer is 20% of the dry weight. Okay, now question number 83 is not our technical question. Okay, so ignore it. Now coming to question number 84, it is from the transportation engineering. Okay, so they are asking retarder. Retarder is nothing but a negative acceleration. Okay, so retarder will be equal to F into G. So F is given as 0.36 into 9.81. So this value will be 3.53 meter per second square. Okay, so option D is the correct answer. Coming to question number 85, option C is the correct answer. This is from the tunneling topic. Okay, one question came from the airport and this question is from the tunneling. Okay, coming to question number 86, hydrofluorocarbon, that is HFC, it helps in reducing global warming. Due to HFC, it does not contribute in global warming, but actually HFC contribute in global warming and its contribution for ozone depletion is 0, but it helps, it contributes in global warming. Okay, now for this question, option A is the correct answer. Okay, coming to question number 87, option B is the correct answer. Coming to question number 88, fine aggregate are those which passes and retain on which of the following size of IS sieve. So it will be between 4.75 mm to 75 micron. Okay, so option B is the correct answer. Okay, if it is less than 75 micron, then it will be called as silt. Okay, if it is greater than 4.75 mm, it will be called as a coarse aggregate. Okay, so since we are talking about fine aggregate, so this should be in this range only. Okay, now coming to question number 89, it is from the transportation engineering. According to Nagpur plan, the Indian road has been classified in how many categories? Okay, they have been categorized in 5 types. Okay, first is national highway, second is state highway, third is major district road, and fourth is other district road, and fifth is village road. Okay, now coming to question number 9, it is from strength of material. Okay, so they are asking if L is the length of the rod and T is the temperature increase and alpha is the coefficient of linear expansion and E is the Young's modulus, then free expansion of the rod due to increase in temperature is given by. Okay, this will be alpha. T would be the answer, but it is not given in the option. So option D is the correct answer. Coming to 91 question, it is again from the CPMM per topic. Option C is the correct answer. Okay, this is also a CPM per question. Critical part define shortest duration needed and longest duration permissible. So option B is the correct answer. Coming to question number 93, it is from the engineering hydrology subject. Only one question came from the engineering hydrology. Okay, and here the answer is B here. This question number 94 is again from geotechnical engineering subject, from stability of slope topic. The answer for this question is C. Mobilized fraction angle is given by tan inverse of tan pi by f. Okay, now stability number Sn will be equal to C by Fc into gamma h. Why I am telling this formula is, in this year, in 2019 GATE, he has asked this question for 1 marks. Okay, so that's why I am telling you stability number is equal to C by Fc into gamma h. Okay, now coming to question number 95, it is from the fluid mechanics. All these 3 statements are correct, venturimeter, manometer. So option D is the correct answer. Okay, here this question is from the open channel flow topic. In the question it is saying that hydraulically efficient rectangular channel of bed width 5 meter. Okay, so there is a rectangularly channel like this and bed width is 5 meter. Okay, so hydraulic radius is, okay, so hydraulic radius R will be equal to A by P, area by wetted perimeter. Since it is here we don't know the depth of the flow. Okay, so since it is a hydraulically efficient, so this depth Y will be equal to 2 times the width B. So here B is given as 5 meter. So Y will be, for hydraulically efficient rectangular channel, this width will be equal to B by 2. So depth of the flow will be equal to 5 by 2 equal to 2.5. Okay, so area will be equal to 5 into 2.5. Okay, so this area will be equal to 12.5. Okay, and wetted perimeter P will be equal to, okay, wetted perimeter is nothing but this length plus this length plus this length. Okay, so that is, this is Y, so Y and this Y, so 2Y plus B, so Y is 2.5, 2 into 2.5 plus 5, this will give us answer as 10 here. So hydraulic radius R will be equal to A by P, so A is 12.5 by 10, so answer would be 1.25. Okay, so option A is the correct answer here. Okay, again this question is from the irrigation subject, from canal outlet topic. Question is saying, if the channel index at an irrigation outlet is 5 by 3, setting of an office type outlet in order to have proportionality is. Okay, now in case of proportionality, setting is equal to outlet index m by channel index n. Okay, now for office type, the channel index, outlet index m would be equal to 1 by 2. Okay, so this will be equal to 1 by 2 by 5 by 3. Okay, then if you solve this, I will get a setting equal to 0.3. Okay, so option 4 is the correct answer. Option B is the correct answer. Okay, this question number 98 is also irrigation question. Okay, from the water requirement of crop topic, and this is a IES question. It was asked in the year 2013. Okay, if you see the question, in an irrigation project in certain year, 60% and 46% of the cultivable command area in Kharif and Rabi season respectively, okay, remain without water, and rest of the area get irrigation in that year for the project was. Let us read this question again. There was a typing mistake, so I have just corrected. So let us read this question again. In an irrigation project in certain year, 60% and 46% of the cultivable command area in Kharif and Rabi respectively remain without water, and rest of the area got irrigation water. Okay, the intensity of irrigation in that year for the project was. So he is asking intensity of irrigation. Okay, so he is saying that suppose 100% area is available. Okay, out of this 100%, only 60% of the water was not this 60% of the land. 60% of the land was not irrigated. Okay, so that means only 40% of the land was irrigated for the Rabi season. Okay, whereas for the Kharif season, whereas for the Rabi season 46 was not irrigated. That means 54% of area was irrigated. Okay, I will write it down here. Area irrigated in Kharif is equal to 40%. Okay, that is 100 minus 60 here. Okay, now area irrigated in Rabi, so this will be 100 minus 46, so this will be 54%. Okay, so then intensity of irrigation will be equal to 40 plus 54, so this will be 94%. Okay, so option D is the correct answer. Okay, here this question is from geotechnical, from consolidation topic. Initially in this question it is saying that there is a single drainage and it took 1 year to settle 10 centimeter. Okay, let us discuss this question number 99 again. This is a geotechnical question from the consolidation chapter. If you read the question, a 1 meter thick layer of saturated clay drain at both the face settles by 10 centimeter in 1 year. Okay, so if a thick layer of pervious soil is introduced in middle of this year, then what will be the period duration which the settle of 10 centimeter will be compacted. Okay, now he's saying we can use here to solve this problem, we can use the relationship of a coefficient of consolidation. CV is equal to TV d square by t. From this relation I can say that t is proportional to d square. Okay, so from this I can say t2 by t1 is equal to d2 square by d1 square. Okay, so here t2 is not known, t1 is 1 year. Okay, so 1 year is equal to d2 is 0.5. okay, since drainage phase here was initially both the phase, then it got reduced to single phase, so d2 is 0.5. okay, it got half. Okay, by 2 by d1 is 1. okay, so if we solve, I will get d2 value equal to 0.25. okay, so option C is the correct answer. Okay, so actually this is IES question, and this question was asked in the year 2009. okay, this is 2009 IES question. okay, coming to question number 100, it is also a geotechnical question. okay, from the soil exploration chapter. Answer to this question is a medium dense. okay, so this is the complete analysis of KPSC AE civil question paper for the year 2007. okay, if you have liked this video, please subscribe to our channel. okay, thank you.